GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A force F equal to 20 plus 10y acts on a particle in y direction where F is in newtons and y is in meters. Work done by this force to move the particle from y equal to 0 to y equal to 1 meter is. Given force is 20 plus 10 y in y direction which is in newtons. Then what is the work done? Work done is the dot product of force and displacement in that direction. Therefore, total work equal to integral y equal to 0 to y equal to 1 f dot dy. Okay. Now it can be written as integral 0 to y f value equal to what? 20 plus 10 y dy. Integrate and apply the limits. It is equal to integral 0 to y equal to 1, y equal to 1, this y equal to 1, integral 0 to 1, 20 dy plus integral 0 to 1, 10y dy. Now you simplify it. Here it is 20y, apply the limits from 0 to 1 plus 10 y square by 2, simple mathematics, from 0 to 1. It is equal to 20 into, let us apply the limits, y equal to 1 to y equal to 0, 1 minus 0 plus 10 by 2, y square is 1 square minus 0 square. It is equal to 20 plus 10 by 2 is equal to 25 joules or Newton meter. That is the answer. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. A body initially at rest and sliding along a frictionless track from a height of h as shown in figure. Initially, the body may be at this particular position and it is sliding down towards the base. Just completes a vertical circle of diameter AB equal to D. Here vertical circle of diameter AB is given as D. Then the height h equal to, very simple problem. Dear friends, remember for completing one circle, the velocity v equal to root over 5 gr. This part already we have clearly discussed while we were discussing the theory concepts. Do you remember? By the time the particle is completing one vertical circle, velocity is root 5 gr. Then conservation of conservation of energy is, potential energy initially the body is maintaining, potential energy initial must be equal to kinetic energy final. By the time it reaches to ground, it is maintaining only kinetic energy. Kinetic energy final means at the ground. Potential energy is what? mg h mgh equal to half into m into v square. Since v equal to root 5 gr, I can write that v square equal to 5 gr. Right? Here it is mgh equal to half into m into v square is 5 gr. Now you simplify it. This m is cancelled. Of course, g also cancelled. Finally, it is h equal to 5 by 2, r equal to what? D by 2. Then it is asking h equal to 5 by 4 5 by 4 d, that is the height of the right particle before it starts to sliding down. So the it is asking the height of the particle equal to 5 by 4 into d. Option D is absolutely correct. Understood clearly? Simple problem. Similarly, let us take the Another important problem. It is asking like this. One end of a string of length L is connected to a particle of mass m, and the other end is connected to a small peg on a smooth horizontal table. If the particle moves in circle with a speed v, the net force on the particle, right, that is towards the center, will be equal to, the centripetal force is providing the required tension in the string. Okay, let me write that point. Centripetal force, that is m v square by length L, mv square by L or mv square by r, you can write. R equal to radius of rotation. Centripetal force providing the tension in the wire. The tension in the wire. The wire means string. Therefore, the net force acts on the string is equal to, right, the tension developed only. Therefore, net force, the net force on string, the net force on string must be equal to the tension developed in the string. Tension developed in the string. Since it is asking the net force on the particle, right, means net force on the string which is connected to the particle is tension only. Option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. Consider a drop of rainwater having a mass 1 gram falling from a height of 1 kilometer. Mass of the raindrop given 1 gram equal to 1 into 10 power minus 3 kilogram, and it is available at a height of the rain droplet from the surface of the ground is 1 kilometer. It is equal to 10 power 3 meter, because 1 kilometer equal to 1000 meters. It hits the ground with a speed of 50 meter per second. That means initially the drop is there at a particular height where the initial velocity u equal to 0. U equal to 0 means initial velocity u equal to 0. Whereas the final velocity of the droplet v equal to 50 meter per second. This is the final velocity of the droplet. Final velocity. Okay. Take g, acceleration due to gravity g equal to 10 meter per second square. The work done by the gravitational force and work done against the resisting force of the air. Here you need to decide work done against the gravity force or work done due to gravitational force. Second one, work done due to air resistance. First, let us decide the work done by gravitational force. Work done by gravitational force is equal to m into g into h. That is the work done by gravitational force. This is equal to m equal to 1 into 10 power minus 3, g 10, h equal to 10 power 3. This 10 power 3, 10 power minus 3 cancelled. It is 10 joules. That is the work done by gravitational force. Now, for deciding the work done against the air resisting force, we need to take the law of conservation of energy. From law of conservation of energy, from law of conservation of energy, initially it is having the potential energy, initial potential energy plus work done against the air resistance must be equal to final kinetic energy minus initial kinetic energy. Anyhow, here initial kinetic energy is 0 because initially the droplet is at a rest condition. Then initial potential energy is what? mgh plus work against the air resistance plus half into m into v square. From this, right? From this I can write that work against the air resistance equal to half m v square minus mgh. So work against the air drag equal half into m equal to what? 10 power minus 3 v square, v equal 50 square minus 10 power minus 3 g10 h10 power 3. This 10 power 3, 10 power minus 3 cancel. It is 50 square equal 2500 divided by 2 into 10 power minus 3 minus 10. It is equal to 1250 into 10 power minus 3 minus 10. It means 1.25 minus 10 equal to minus 8.75 joules. That is the work done against the air resisting force. So work done due to gravity force is 10. Work done against the air resistance is minus 8.75. Look at the options. 10 joules work done due to gravitational force and resistive force of the air is minus 8.75. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem asking like this. It is asking like this. A particle moves from a point, let R1 bar equal to minus 2 I cap plus 5 J cap and is moved to that I can write as R2 bar is equal to 4 J cap plus 3 K cap. Okay. When a force acts on the particle equal to 4 I cap plus 3 J cap, it is in newtons. The distance may be in meters. How much work has done by the force? What is the work done? As you know, work done equal to dot product of force and the displacement. The displacement R bar equal to, I can say, R2 bar minus R1 bar. Let me write those values. R2 bar 4 J cap plus 3 K cap minus 2 I cap plus 5 J cap. It is first I cap minus and minus plus 2 I cap plus 4J minus 5J minus J cap plus 3K cap. That is the displacement. Then work equal to force 4 I cap plus 3 J cap dot displacement 2 I cap minus J cap plus 3 K cap. Multiply I to I, J to J and K to K. I to I, here it is 8, right? J to A minus 3, right? K, no, there is no K part in the force. That's it is equal to 5 joules. Since it is a work is a kind of energy. Work unit is joules or Newton meter. This is the 5 joules. Understood clearly? Yes. Look at the option. Option C is absolutely correct.
GeopByte.